Millennium Machines just released updated config files and firmware for the Milo 1.5. This is available both for their reference platform as well as the configuration for the Milo 1.5 LDO kit. I'm going to talk about how you install that firmware. We're going to talk about how you work through installing the Millennium OS system. This isn't an operating system, but it's referred to as an operations system. It's a collection of macros that make it easier to use your Milo. I'm also going to talk about how to use an optional touch probe. That's not part of the LDO kit, but you can get them online from a lot of different vendors. They're roughly $50 to $80 US. The touch probe makes getting your coordinates dialed in a lot quicker rather than having to manually probe your workpiece. So let's start by talking about the touch probe, and then we'll go into the firmware. Your probe will come with a cable that has a USB-C connector on one end and 3 bare wires at the other. These are plus, minus, and signal. What you need to do is pin these to a JST connector to go into an unused end stop on your flyboard. I've used the WiMAX port because I'm not using that for anything else. You can make sure that this is wired correctly by plugging it into your touch probe when the machine is powered on. You should get a green LED, and if you gently deflect the pin, that should turn red. So we know we have power. That is all you need to do for the physical setup of the touch probe. Now let's go in and set up our firmware, and then we can deal with the software. To get the file that we need, we'll go to the Millennium Machines GitHub account, go into the RFF configs repository, and download the latest release. Once you've downloaded that file, expand it. You'll select all of the files that were in that zip archive and then put them on the root of your micro SD card. Be aware that doing this installation will overwrite anything that you've previously done with your flyboard, but this will upgrade you to the latest files from Millennium Machines. So just copy this to your micro SD card's root, put it in the flyboard, and then turn your machine on. This will automatically install the firmware and the newest configuration. This firmware update will configure the Milo's Wi-Fi chip to be in access point mode. So it's going to generate its own Wi-Fi network. The name of the network is Milo. The password will be Millennium Machines, and it will be at the IP address 192.168.40.1. This is done to make it easier for you to connect to the machine the first time. There's a link to instructions on how to do that on the page where you downloaded the firmware. I will say I'm going to leave mine in the access point mode. The Wi-Fi chip in the flyboard isn't terribly fast, so it's quicker to have your client connect directly to that rather than the Milo connected to your home router, then a laptop connected to your home router. That gives you 2 Wi-Fi hops for every request from your laptop to the router to the Milo and the same back, versus your laptop being connected directly to the Milo. I did find it to be just a little bit more responsive in access point mode. So here I am in my web browser. I've got my laptop connected to the Milo Wi-Fi network, and I've got the Duet web control system up. One thing that we have to do for our touch probe setup is go into the System tab under Files, open up config G, and we need to put in this string. The M558 defines the probe. As I said, I put this on my max Y end probe, so this is the format for that pin, Y stop max. I found that I had to invert this pin, which is why there's an exclamation mark in front of it. That's something you're just going to have to try. I think it depends on the actual probe that you have, whether it works inverted or not inverted, but we'll see once we get more into the Millennium operations system. So you would save that, and then you would want to restart. At this point, we're ready to start doing some pre-flight checks. So the first thing that I'm going to do in Preflight is I'm going to check my end stops. If we go to the console and put in an M119, we can see here that none of my X and Y are not stopped. My Z is actually at max stop because the spindle is actually homed. Now, if I go back and I'm going to hold down the Y end stop, resend this, we can see Y is now at max, and I will reach over here and hit the X end stop, and now we can see X is at min. That is correct for the way the coordinates are set up. And we're already seeing that Z is at max stop. So at this point, I should be safe to go and home. As with any new setup, the first time that you home, I would definitely have your hand near an emergency stop, whether that's the emergency stop button on the front of the machine or hovering your mouse over the emergency stop in the firmware. You just want to be able to stop this in case something wrong happens. So, and my machine homed correctly. So let me jog this back a bit. And I can bring Z down. Okay, so we have motor control, the end stops worked, we were able to home. I'm going to test the spindle. You can see that there is currently a dowel in the spindle. Before I started this video, I confirmed that that nut is properly tightened. Before you do anything with a spindle, if there is a tool in it, you should definitely check that that nut is properly tightened. If it's not, and you've got the spindle spinning at 24,000 RPM, that could potentially loosen, go flying, damage can happen, no fun. So just make sure that that is tightened if you're turning the spindle on with anything in there. That said, what I'm going to do now is scroll down to the RPM section here for my spindle control. Now, once I type the speed into the set RPM, you may hear the relay click that it's active. The spindle will not turn on until you hit enter to confirm the RPM. So just be aware of that. It can kind of fool you if you hear the click and you're like, my spindle should be turning, why isn't it? I'm going to turn it very slowly because I want to make sure that it's turning in the correct direction. My spindle and most others have an arrow here to indicate the direction that the spindle should be turning. So I'm just going to fire it up to about 2000 RPM and feel that dowel to make sure that it's turning in the correct direction. And it is turning in the right direction, so I can just turn the spindle off. The other thing you'll see is I do have this dowel in here. We're going to need that for the MOS setup. You should have that dowel in somewhere between 15 and 20 millimeters of stick out. One thing that I would do is actually jog the bed over and bring your spindle down to make sure that this dowel can make contact with the fixated plate. We're going to need to do that in the MOS setup. It's better to find out now that if your spindle needs to be adjusted than later. Ask me how I know. So if you do that test and the spindle can't get low enough to touch this dowel to the plate gently, what you would do is loosen up your spindle mount, slide the spindle down a little bit, and then check it again. The other thing that we're going to check is if we go back to the Duet Web Control, you can see we've got the Z probes here. So if I hit the tool setter, my second probe goes from 0 to 1000. So we know the tool setter works. And if I activate the touch probe, the second probe works. So RepRap is seeing the touch probe. I've got everything up and running. The machine has passed its pre-flight. If yours does not, fix those problems now, because you don't want to have to deal with them once we get into MOS. The way to install MOS is once it's available, you will go to the repository on the Millennium Machines GitHub account. You'll download the zip file as well as some other files that you need to install in Fusion. If you're using Fusion to do your manufacturing control, you'll take that zip file. If you go to the web control for the Milo, you go to Files, System, and Upload System Files. And from there, you'll be able to pick that zip file that you downloaded. You don't have to extract it. You can just upload that directly. You'll get a dialog showing that it's installing a bunch of things. You will then need to restart RRF. One way you can do that is go up to the console and do an M999. That will restart. From there, open your config.g file again, and after the line where we put in the touch probe, put in this M98 command, which will load the MOS configuration file. Again, restart your machine. That will bring up the configuration wizard. Mine isn't coming up because I already did this, but what we can do is now if we go down, let me go back to the dashboard. You'll see under macros, there's this Millennium OS directory, which gives us all of our macros there. We can print variables, we can reload. If we go here, config, we'll run the configuration wizard. So this is what you would normally get when you reboot after including the MOSG file. So we'll say OK. This just tells us that nothing is going to be saved until you complete. That is being worked on now so that if you get partway through your configuration and there's an error, you have some other problem, you'll be able to save where you have gotten to and not have to redo the whole thing. But at the time of this recording, you don't save until you're complete. Yes, we need to, if we cancel, we have to complete. Yes, that's the thing. We're going to make sure that our jog button distances are fine enough. Those are pretty good as they are from the factory. If you need any help, ask on Discord. I'm going to leave this in tutorial mode, which will continue to give us all of these very verbose warnings and telling us what we're doing. I do not want to enable expert mode. I'm going to restart and do the whole thing again. So this is just telling us that we need to have our spindle and our probes already defined within RepRap firmware. MOS doesn't define them, it can only reference them. Since we've gone through our complete pre-flight, that's done. So that is indeed my spindle. At this time, do not enable the spindle feedback feature. That is a feature that is still in development. So what's going to happen is when I hit OK in this dialog, the spindle is going to speed up to full speed. Once it's at full speed, then I need to hit OK again. What this is doing is letting the wizard time how long it takes for the spindle to get to full speed. Then it's going to time how long it takes to stop turning. What I like to do when I do this is I'm actually looking at the back of the machine. to see the frequency display on my VFD, so I know when that gets to 400, the machine should be at full acceleration. So I'm going to go ahead and trigger this, and we'll step through the speed up and speed down. So now that we've done that, we need to choose a datum tool, which is the dowel that I already have in the spindle that came with the LDO kit. So if the touch probe is disabled, then this is what would be used to probe the workpiece and calculate tool offsets. With it enabled, this will just be used to take initial measurements. So once this is configured, you have to use the same tool. So we have to enter the radius of the tool. This is set up for a 6mm dowel. Mine is actually 10, so that would be a 5mm radius. We do want to enable the tool setter, and here we do want to enable the touch probe. So the back off distance is how much the spindle will lift when doing protected moves, and 0.5mm should be fine. So now it's going to detect the tool setter, and to do that, I just tap the tool setter, and it says that it's been detected with ID 1, which is correct. The datum tool is already installed, and I know that it has that stick out. What I have to do now is jog the bed so that the tool setter is under the spindle, which will let us set the position for the tool setter. So I overshot it a little bit there. And that's reasonably close. Let me check it from the side. And I'll bring that down a bit. This is telling us that we want it less than 10mm over the tool setter. And I'm still getting used to the coordinate system here, so bear with me. So that looks good, and now when I hit OK, that's telling me what the position is, and so now it's learned where the tool setter lives. Now we need to probe a flat reference surface, which I'm going to use the bed. Yes, the machine table itself. And yes, we need to be very careful doing this. So let me So what we need to do here is get this dowel close to the bed, but not touching it. So let me... So less than 20mm. Well, that's less than 20mm. So when we click through now, we're going to go into a fine adjustment mode. We're just going to bring this down a little bit at a time. I think I've got one more 1mm. That's good. And what I'm doing is just bringing this down. Okay, that's a little bit too much. You just want to feel drag on the spindle. Well, that's definitely it. So we're going to finish that. And there we go. So we are instructed to now remove the datum. There we go. So I have removed the datum. Now we need to detect touch probe. So let's get that guy. It's waiting for me. Touch probe detected with ID 0, which is correct. The radius of this touch probe is 1. I've already measured that. So we're going to measure the deflection. We're going to do this by probing a 1, 2, 3 block or other rectangular item of accurate and known dimensions, which we have. And that is installed in the machine now. And we're going to move the table to the front. Secure your 1, 2, 3 block or chosen rectangular item, largest face on top, which I've done. So we're going to enter the exact surface length. Uh, 50.79, yeah, I'll take that. And 76.2. 76.21. Okay, close enough. What we need to do now is mount the touch probe. I have to change collets. This is one place where having a 6mm dowel pin would be handy. So I'm just going to start the nut, grab my probe, which is connected. Put that in, and you don't need to crank down on this. Well hand tightened should be good. And jog the probe within 5mm of the center. So X. Again. Okay. I think I overshot there a bit, but let's get it. And let me bring this down. Okay, so it's actually a little forward. Okay, that's pretty close to the center. And, you know, I'm actually going to take this up a little bit. Because it tells us that the probe height is assumed to be safe for horizontal moves, and I want to make sure that that is high enough to clear the bolt that I have holding the block in place. Okay, so now we have to set the probe depth. So we're going to tell the system how far down it needs to go to safely probe. So that's just about 10 millimeters. So if I say 13, and this is telling us that it's going to go 15 millimeters from the outside of each surface, 2 points each at a depth of 13. So that's got our results. So it's telling us that we can remove the touch probe and stow it. And I'm going to remove the collet to make sure that no hilarity ensues. And that's it. Our configuration is complete. That's going to reload. And hey presto. And that's it. That is the firmware installed, the Millennium OS installed and configured with a working touch probe. I really want to thank the members of the Millennium Machines crew, not only for designing this machine, but also for giving me permission to go ahead and talk about the upcoming MOS release, show how that's done. The new configuration is great. My Milo just worked out of the box with it, so that was fantastic. The MOS system will really help speed up operations when used in conjunction with the add-on post-processors for Fusion, which I will be talking about as soon as I figure out how to generate my toolpaths. I really would like to get this machine cutting something within the next week. So hopefully you found this helpful. If you have any questions, you can ask in the comments. I'm also over on the Millennium Machines Discord server, as well as the entire crew, Jake, Dave, Ben, Phil, Ed, everyone involved with this project is very active over there. So it's a great opportunity to be able to ask questions not only from people that are building the Milo, but the people that designed it. So that's it for this one, and I will see you with another video soon.